Hello everyone. Let me start with a thought. Have you ever noticed that when you roll a ball on the floor, it slows down and eventually stops? But if you imagine rolling the same ball on a perfectly smooth ice surface, it would keep going much longer. Now the big question is, does motion naturally die out, or does it continue forever if nothing stops it? This is exactly the question Galileo asked centuries ago. He studied the motion of balls on inclined planes. What he found was fascinating. Balls rolling down an incline speed up, those rolling up slow down, and on a horizontal surface they move without gaining or losing speed. His conclusion? If friction could be removed completely, a ball on a horizontal surface would continue to move forever with constant velocity. To confirm this, Galileo tried an elegant experiment with a double inclined plane. Imagine a ball rolling down one slope and climbing up another. He found that the ball always climbed nearly to the same height from which it started, a little less, because of friction. In an ideal case with no friction, it would exactly reach the same height. Now, here's the twist. If the slope of the second plane was made gentler, the ball traveled a longer distance before climbing back to the same height. In the limiting case, when the second plane was made completely horizontal, the ball never climbed. Instead, it rolled on forever. This was a revolutionary insight. Motion doesn't end by itself, it ends only because something like friction stops it. Of course, in real life, the ball does eventually stop. Why? Because the horizontal surface always has some friction. This unavoidable opposing force gradually brings the ball to rest. But here's the key lesson. If friction were absent, the ball would keep moving with constant velocity forever. That's the true law of nature. Galileo realized that friction hides this deeper truth from our everyday experience. So what did Galileo ultimately conclude? He said that the state of rest and the state of uniform motion are equivalent. Think about it. A book lying quietly on a table and a satellite orbiting Earth at constant speed are both in natural states of motion unless an external force disturbs them. In both cases, the net external force is zero. This insight completely overturned Aristotle's belief that motion always requires force, and it laid the foundation for Newton's first law. Galileo had essentially discovered the law of inertia. Now let's define this idea clearly. Inertia is the natural tendency of a body to resist any change in its state of rest or uniform motion. If no net force acts, a body at rest stays at rest. Similarly, a body in motion continues to move uniformly in a straight line. You see examples of inertia every day, times when a moving bus suddenly stops, passengers lurch forward. Their bodies resist the sudden change. Times when you shake a dusty carpet, the carpet moves but the dust tends to remain where it was, so it flies off.
Let's work through an example to make it crystal clear. Suppose we have a block of mass 2 kilograms sliding on a perfectly smooth, frictionless surface with velocity 4 meters per second. Now, no external force acts on it. Step 1. Net external force, F equals 0. Step 2. Acceleration, A equals force divided by mass, which is 0 divided by 2 equals 0. Step 3. With 0 acceleration, the velocity does not change. So even after 10 seconds, 20 seconds, or even 100 seconds, the velocity remains 4 meters per second. This proves that on a frictionless surface, no force is needed to maintain motion. Motion continues indefinitely until some external force acts to change it.
Let's quickly revise. Galileo's experiments showed that motion continues unless opposed by friction. A body at rest and a body in uniform motion are equivalent when the net external force is zero. Inertia is the natural resistance of objects to changes in motion. This idea directly led Newton to formulate his first law of motion, also called the law of inertia. So to sum up, motion does not require a continuous push. Only changes in motion, starting, stopping, or changing direction, require a force. I hope you now understand how Galileo's discovery reshaped our understanding of motion and why inertia is a cornerstone of physics. See you in the next session where we'll dive deeper into Newton's first law and its applications in the real world.